All right, so we're being recorded, and basically the class is split up into 3 units. I was explaining this earlier to Danielle. Unit 1 is where we're at right now, and you won't see all of the work that's assigned except at the beginning of each of the first 3 Sundays. So yesterday, what opened up was homework number 1, homework number 2, and homework number 3, and also practice number 1, practice test 1. So these are that's all you see right now. If you go into your
yeah, that's what I saw.
right, that's all. And you may not see practice number 1 unless you look at the whole month, because if you look at 2-week intervals, all you'll see is this. But if you tell it you want to see the whole month, then it'll also have practice number 1. So you do these. We're going to do homework number 1 today. Tomorrow we'll do homework 2, and Thursday we'll do homework 3. And we're done. And then you get test number 1.
Now that you said Thursday, I will not be here Thursday. I picked up a shift for work before I leave.
Okay, so then it's up to you to watch the video.
I will.
To catch up, because that's the culmination of everything we're doing for test number 1. It's going to be pretty important. All right. But there's other things you can do besides that. Anyway, homework number 1 is due Wednesday night. Now, when I say due, I mean midnight. It's always midnight, 11:59, end of day. There's no time limit. You can go in starting today, because it says on the calendar, start homework 1. Because we'll be discussing it. It's fresh. Start on it when you get home if you want. You don't have to finish it. When you come back, you pick up right where you left off. And whatever you complete by Wednesday midnight, it's worth 100% of your effort. So if you get it all correct, it's 100. But there's a 48-hour window for grace. That if you didn't finish it, you can still finish it by Friday. But for anything you didn't finish by Wednesday, you lose 10% of those problems. So if you didn't do anything till Thursday and Friday and you got it all correct, the highest score you get is a 90. Follow? Okay. So homework number 2 is due Friday, and the last date is Sunday. Homework number 3 is due Sunday, the last date is Tuesday. Okay? Now when you get all 3 of these done, you're ready for test 1, but you won't open up till Sunday. And it's due Tuesday. First attempt. If you don't like your score, you can do it a second time by next Thursday. Okay? There's no deductions, there's no changes. Higher score stands. So if you got an 80 and you say I can do better than that, and you get an 85, then 85 is the score that stands. But if you get a 79, then you keep the 80.
Okay.
All right? So homeworks, every problem you get 3 chances. Except to fill in the blank, like a word. If they're multiple choice or a numerical problem, you get 3 tries. Because sometimes, like I was saying, you might have the wrong number of decimal places, or you might put a capital X instead of a lowercase x. And you notice, oh God, or like you're like me, you got fat fingers, and you hit the wrong key, and it counts it as a try, and you haven't finished entering all your numbers. So you get more than 1 try. You get 3 tries.
Okay.
But if it's a fill in the blank, asking you for a name or something, you only get 1 try. Those problems are only worth 1 point anyway.
That works.
All right, so,
Not bad. Yeah.
so there's no time limit on these, just deadlines.
Okay.
These I think are 2 hours.
Okay.
I'll double check, but they're 2 hours. Once you start, you got to finish each time you start. So you get 2 tries. So next Sunday, test number 1 will open up, or this coming Sunday, and then homeworks 4, 5, and 6, and practice number 2. And then unit 2 will consist of 3 homeworks, which we'll do Monday, no, we'll do Tuesday, Thursday, and the 3rd Monday, because if we have next Monday is Easter. So we push things back a little bit. Because we got 4 a week, so we might as well use them. And then you get test number 2. So this unit 1 is all algebra, as I was explaining. It's just review of algebra, graphing. It leads up to a thing called linear programming. Basically what it is, it's typically in the first quadrant, and you form, you have lines that you form, and you form a quadrilateral. And that's called the feasible region. And our goal is to take these 4 points, the corner points, the vertices, and put it into some objective function like for profit. And the profit might be $7.50 times X plus $10.35 times Y. Maybe skateboards and shuffleboards or whatever. And you try to maximize or minimize P depending on the values of X and Y at those 4 points. And that's where we're headed. But we have to review how to draw graphs and how to find ordered pairs. So we'll do a lot of review. You took 1033, right?
I did, so it's still fresh in my head.
Oh, that's good. That's good. Then you can help me and her.
Yeah, you can help me.
But that's where we're
I
headed.
walked in here and I told him, I was like, you don't even, I'm petrified to be in this classroom.
These 2 are going to be a metric system.
Okay.
This one is going to be the introduction to simple interest and simple loans.
I'm going to be hiding under my desk for that one.
Well, that's the end of the course is all finance.
I tried the Series 7. This is probably about 10 years ago. I missed it by.
I'm not sure what Series 7 is.
It's to become a broker.
Oh.
The exam they were giving, and all that fun stuff was on it. I missed it by like a couple of points.
Well, you'll do okay, I'm sure. I'll help you.
We're in this together, girl. Don't worry. I should have taken this class before I took that exam.
So on the third Sunday, a week from this Sunday, then these will all open up, and then the third part is the last 3 homeworks.
So is there a discussion post in this classroom?
A discussion?
Is there a discussion post?
A discussion.
They have to post discussion. Yeah, like discussion in Blackboard. In Blackboard.
We discuss math all the time. We don't need to do anything.
Oh, no, that's one. This will be the first class that I don't got to do that. There's a couple of.
They have.
Is there?
They have. If they pop up, just ignore them.
Okay.
I try to.
They're not there. Not for this class. Yeah, like I saw them in the grade book, but just like I entered a computer class, there were things that were on there that he didn't. He was like, don't worry about that. It's going to be done.
All right. So the last part is all finance. It's long-term loans, mortgages, and retirement funds. Okay. Stuff that you should probably be interested in. I'll make it interesting.
Yeah.
And so.
Stuff that I need. Yes.
There's no final exam. There's just 3 tests.
Okay.
Each test stands on each unit alone. Because they're separate material, there's no sense in me giving a final exam. I don't believe in it anyway.
Okay.
I'm just here to see what you can do with what we got. So, the 9 homeworks are a total of 35%. So that's 3.89% apiece, just about 4%, right? 9 times 4, 36. Mm-hmm. And you got 3 tests. They're worth 20% apiece. Then you got the post test, 5%. KU wants you to do that all the time, and you'll see a big improvement. You guys will improve 50 points on your post test, and there's your 100%, right? Mm-hmm. Okay, these 2 will open up on Wednesday of the last week. So by then we will have covered all of this, and then you have, like for instance, test number 3, first attempt, you can do Friday of the 4th week, or these can both be handed in Sunday midnight, the last day. That's really nice because we don't have to do testing in here on Thursday, and you got 3 more days for the class technically. This way you can do them if you need to. A lot of people get them all done early because they want to see how they did, and they want to try to get a second chance if they can. I can move things back. What's the first, like, this is due Wednesday. If for some reason you can't finish it by Friday, I'm willing to move it back to Saturday, but you still incur the 10%. I don't add anything else on. I just keep the 10% once the first deadline passed.
Okay.
But I'm willing to, like if you're in the third week and you look at homework 2 and you say, oh, only got an 85, yeah, I'll open it up for you. You can go back and try to move it up. If there's problems that you can still work, if for some reason you didn't finish it, you know what I mean?
Yeah. Okay.
So I'm willing to do that, but you'll get 90% of whatever's available, provided you didn't already finish the whole thing. All right, so each test you can take twice. Each homework has double deadlines. And so I would try to keep pace. You can't really do this until you finish these 3, and you can finish these 3 by the first weekend, and then on Sunday you're actually ready to start test number 1 before we start next Tuesday on homework 4. You know, you got time to, I should tell you, the practice test, you got 10 hours on it. And it's just like the test, I mean, as far as format. Right. You know, on a homework, if you get the wrong answer, it tells you it's wrong and it gives you a second, third chance. On a test, you give the answer, you don't find out if you got it right or wrong until it's done. But the problems for all the homeworks and all the tests are from the same place. You know, it's just that every time you open up a homework problem, the numbers change. And every time you open up a test, the problems change a little bit, because there might be 20 problems in the test, but each problem has 2 or 3 selections randomly. So they're randomly selected and they're random numbers. But they're basically the same problem. It's just that I don't want to have everything exactly the same. So, but there's 10 hours on this, on the practice. You could use it to your heart's content. 10 hours that's 600 minutes. That's a long time. Most people don't use it. I don't know why, but some people do. Some people use it and they get a feel for what the test is like, because that way you don't waste your first attempt because you weren't prepared.
I like the My Math Lab. We used it for the other 2 math classes that I had here, and it's really good. I was telling Dr. Keiser, we use SimNet, which is it's pretty much just like Pearson, but for intro for Microsoft 365. I love their program. It was really good. I did the intro to computers. Yeah. I did it like 2 months ago, I think. Yeah, I like SimNet.
So, any questions about this?
No, sir. No, not at all.
All right, so that's it. There's only 13 assignments. That's it.
That works. And it's open already, the homeworks for this week, right?
But yeah, these 3 are open, and so is the practice test. When you feel you got enough of these, you work far enough on these, you can start your practice test. Like on the weekend, you can go ahead and get it done. You know, I wouldn't work ahead. I've had students work ahead. If you're a real bright student, that's okay. If you catch on, but I just want you to try to keep pace with the schedule, the class schedule. It tells you when to start, when it's due. Tells you what we're doing each day. It's pretty concise. The syllabus has mine. You can call me on a landline if you need to, or you can use my cell phone and send me a text. You notice I texted and emailed you both ways. Yeah. And you can email me. I check my emails a lot. Okay, so let me go ahead and show you some other things here. On the Blackboard, you'll notice on week 1, I say you can request any question. You can request, like, each problem has a chapter, section, and number. This is the Pearson number 6.3.11 of a problem. And while you're working it, if you hit Ask My Instructor, I get an email. And if I can answer your question, I will. Otherwise, I'll make a video. and then I'll send you the link so you can watch the video about how I solve it.
Oh, okay. Oh,
And,
great.
and just so you know, I've already done a lot of them. So here's for test number 1. These are all the problems that people have asked me to do videos for us. For instance, here's 6.6.49. See, I get the problem, and then I show you how to set it up, how to do it.
Oh, okay.
So
Oh, that's great.
we're going to graph that equation. So enough of that, but you get the idea, right?
Yeah.
All right. So there's, for each week, for each unit, there's a new list. So that was week number 1. Week number 2, shorter list for the metrics, and then week number 3 is the finance, even shorter list. You can add to them. You can see these are different types because I add to them.
Right.
They're in my YouTube catalog, and they're my personal property. That way I can keep them.
Okay.
So you can I allow you to look at them and use them. But if you want more of them, then you're welcome to do that. And so while we're at it, then let me show you how that works. So here is this list here, all chapters. This is the entire book. And for each chapter, like we're going to do chapter 6, these are all the sections in chapter 6. So today we're going to do 6.1 and 6.6. Homework 1. And see, if I open up homework 6.1, these are all the problems from section 6.1. They mimic a lot of the problems in the book. Now, half of these are homework, half of them we're going to do in class. Now, there may be an overlap. I may do a homework problem. You won't know until you get the homework problem. Some of them I don't care. I just want you to get it. I'm just here to help you understand, for me to assess what you learned. That's all. I'm not here to make you jump through hoops, because I know this is just a check mark on your curriculum. You're not scientists. You're not radar specialists or engineers. So I just want you to feel comfortable, and we'll get through this, and you can check it off and go, I did it. Now, what I was referring to, we're going to start on 6.1, but let's just go to this problem. I'll open it up, and I'll show you what I mean. So if I were having problems on how to figure out how to evaluate this expression, it says get more help. See, it says ask my instructor. If I punch that, then I get this problem, just like it sits, comes right to my email. So I can see what you were working on. I can actually work it out. See, if you have an answer in there that's incorrect, I can probably guess how you got the wrong answer. I can send you a quick note saying, try this. Or if I think the problem's really difficult and you need more than just a hint, then I will work the problem out. Of course, it'll be with my numbers.
Right.
Because see, every time you open this up, it's different numbers. Watch. If I just go back one problem and then come back, see the numbers change.
Right.
Everything changed. But it's the same kind of problem. It's a cubic being evaluated. So when you send, when I'm not going to work your problem out because I can't,
right, even
if I wanted to. So what I do is send you a hint, or I'll work that problem out with different numbers, and then I will post it. I have to go through, produce it in YouTube, and then keep it for posterity. But I can send you the link right off of Keiser Live, and you're welcome, both of you, to watch Keiser Live now, because I'm in Keiser Live right now. If you want to go along with me, if this screen's too hard to see, or if you want the small screen to work along, you can do that. Just remember that if you're trying to do homework in here, it's going to be really confusing. I would highly advise against it. Anyway, any questions so far?
No.
All right, so here's what we're going to do. We're going to go ahead and get started. So as I said, section 6.1 and 6.6 is what we're doing today. A lot of review, so let's go ahead and get started. Oh, I didn't tell you about the calculator. There's a calculator on the desktop. It's a TI-83 stat calculator there.
Oh, wow. Is that new?
It's on,
Desktops?
yeah, it's on there. So when you're in here, you could use that. Now, she borrowed one from me. I have them to loan out if you don't have one. If you want me to loan you one, I can do that before you leave today.
Yeah.
Remind me.
Thank you.
All right, so this is our review. A letter of the alphabet used to represent a number is called, and what are my choices? See, this is where you only get one chance at it, I think. Variable constant expression solution. A letter of the alphabet used to represent a number is called, who remembers?
Variable?
Right. Okay. Number two. A symbol that represents a specific quantity is called, well, we know it's not a variable.
Right.
So we got down to three. Term, expression, constant. A symbol that represents a specific quantity.
Function?
Constant, that's right. Constant. Oop. Constant. That's the difference between a variable and a constant, right? If I write 2x plus 3y equals 5, I know my x's and y's are the variables. I know that 3 and 5 are my coefficients, and they're constants. They're constants that I would otherwise write as ax plus by equals c. See, now they're constants, a, b, and c. These are numerical constant, and these are alphanumeric constants. But the only variables are x and y. You see that? You know, this is the general form for a linear equation. This is a specific linear equation in general form or standard form. Some people call it standard, some people call it general. Either one. There's no fractions, right? So if it's in no fractions, then we typically call it a standard or general. So, but a constant represents a specific quantity. So A, B, and C are specific. So are 2, 3, and 5, but I already know that. See, but you see, this gives you a notion of what the definition means. That was an example. A collection of variables, numbers, and parentheses and operation symbols is called an algebraic. We know we can eliminate variable and constant, so it's either an expression or a solution. Expression, right? Because we know what a solution is, right? I think. There it is. The number or numbers that replace the variable make the equation a true statement is called the solution or the solutions. That's what a solution is. It's the number that when you plug it in, it makes it a true statement. Like 1 would work for x and y. The point 1 comma 1 is a solution. See, this is in two variables, so there are points on a line. So this is a solution. It's not the only solution, but it is a solution. If I put in x equals 1 and y equals 1, I get 2 plus 3 equals 5. So this makes it a true statement. So 1 comma 1 is a solution. Number 5, the parts that are added or subtracted in an algebraic expression. What do we call 2x and 3y and 5? What are those called? They're called terms, algorithms, coefficients, ratios. Who remembers? Well, the ratio is a quotient. Neither of those are quotients. Coefficient is the number in front. 2 and 3 are coefficients. Algorithms are a plan on how to solve something, so the only one left is terms. Those are terms, right? Terms. Now that's terms in an equation. You can have terms in an expression. I can turn that into an expression just by making it a minus sign. Now it's an expression. So, right? No longer an equation. Okay. And then there's the notion of terms that have the same variables with the same exponents are the variables are called unlike, simplified, like, equivalent. Who remembers? I told you this would be a review of algebra, so we can. Because when we want to combine terms, they have to be like terms. They have to have the same exponent and the same variable. I can't really add 2x and 3y. I could add 2x and 3x because they're like terms. But these are unlike terms. All these three are unlike. Same down here. There's no alike because they have different variables. In fact, 5 doesn't even have a variable, right? Well, that's not true. You could put a variable in there. You could cheat. You ever seen this? How much is x to the 0? What's anything to the 0 power? Who remembers? 1. So that's just 5. 5 times 1 is 5. But now I cheated. I put a variable in there. It looks like I put one in there. And mathematicians screw around like that. They mess with your mind.
I didn't know that x to the 0 was 1 until I took the class.
Yeah. Anything to the 0 is 1 except 0.
Right.
0 to the 0 is which is we won't go to.
Yeah, no, please don't, not right now. She did that during class, and I was like,
We call it indeterminable.
my brain can't
You
math
can't
right
determine
now,
what
don't
it
do
is.
that to me.
It's called indeterminable. You can't determine what it is. The numerical part of a term is called its numerical. I already told you what it was. See, you can eliminate all the ones we already used. We didn't use proportion, but you know a proportion is a quotient.
Right.
It's a fraction. So a coefficient. That's right. Numerical coefficient. That's what it's called. All right. And then an equation in which the highest exponent of the variable is 1 is called. So this is both of those variables have a. If we don't write the exponent, it's assumed to be 1. Correct?
Right.
Just like the denominator for all those terms is 1. We don't have to write it.
Right.
So what do we call that kind of equation? Where the exponent's 1. I said it already. I'll give you a hint. What's the graph of this? What does the graph look like? If I make it into an equation. I need 2 points on the line. So if I let x be 0, then y equals 2.
It's linear.
Yeah, linear. And if I let y be 0, x equals 3. And if I join those two, I have a straight line. So it's a linear equation. Remember this?
Yeah.
We're going to review this some more today. So it's linear.
It's coming back.
Yeah, I know. That's the whole purpose of this, just to get you in the flow rather than just dump stuff on you. And then an equation that has an infinite number of solutions. Let me show you one. What do you notice about that? If I distribute the 2 on the right, what do you notice?
It's the same equation.
Same equation. So how many solutions do I have? What's the value of x? If these are equal, does it matter what I put in for x?
No.
Infinite
It
number
could
of
be
solutions.
anything.
We call that identity. Identity means there's an infinite number of solutions. There's only 3 types of algebraic, there's only 3 types of possibilities for solutions when you have a typical equation. Either an infinite, or a unique solution, or no solution. They're no longer equal, are they?
Yeah.
That one might be too hard. Let me show you this one. Is there any number that could equal the same number plus 3?
No.
No, that's a contradiction. There's no solution. And then you have a simple equation that has a unique solution. What's the solution to that equation?
Yeah.
X equals 2. Right. Because x equals 2 is an equivalent equation to this. We would divide both sides by 2, we get x equals 2. So they're equivalent. So the solution to x equals 2 is the same as the solution to 2x equals 4. So one unique solution. No solution, infinite solution. Those are the only 3 possibilities, no matter how many variables you have. So this is in 2 space. X, well, this is actually on the line. This is one space. This is on the line. Although you could say these are two different lines. You could say that's Y1, that's Y2, and you could say they never cross. That's why there's no solution. Okay, so identity. That means there's an infinite number of solutions. Number 10, no solution. I already gave it to you, didn't I? Contradiction. Contradiction. And a lot of solutions in math are made by starting with a contradiction. You assume something's true, and it turns out that you're contradicted. So then you know that your original assumption was false. It's called proof by contradiction. So contradiction just means there's no solution. What would be a good one? I don't know if I could do it real quick. 2, well, square root of 2 is not rational. Remember rational? Quotient of two integers. It could be negative, but you can't have 0 in the denominator, right? You can have 0 in the numerator, but square root of 2 is not rational, so assume that it is. So assume square root of 2 is rational. We want to get a contradiction. So if the square root of 2 is rational, let's let it be a over b, two integers. So we just assume a and b are integers. And guess what I do? And it's in lowest terms, no common factors. So I square both sides, and then I multiply both sides by b squared. And guess what? There's no common terms. So 2 can't divide a squared, because if it divides 2b squared, it can't divide a squared. So it's a contradiction. So contradiction, so my assumption is not true. It's a contradiction. Proof by contradiction. And then okay. Now we're going to do some problems. These are all straightforward. Nothing scary. Combine like terms. Anybody want to try?
The only ones that you can combine are the ones that have the x on them, right? That should end up being 9x minus 9.
Careful. Okay, let's say we agreed with you. I really don't. It's going to mark us wrong. What did you do incorrect? No.
You added instead of subtracting. Oh.
It's a negative 2.
Oh, I didn't even see that. Yeah.
Okay. So then, see now, look. This is what happens. I wanted to do this so you can see what happens when you're doing homework. So you say, okay. Now it gives you a second chance.
Gotcha.
So what should the number be?
It should be
the coefficient for x.
2x. No, wait. Sorry, 5.
5. Minus 2 plus 7. Now this, if you're in the groove, see, I can see that as 7 minus 2.
Right.
Mentally. Right? Okay. So then we get a second chance. All right. 19, another one like this, combining like terms. Okay, so now I got 6 terms in my expression. I got x squareds, I got x's, and I got constants.
So you put the x's together, the x's square together, and just a constant.
So how many x squareds are there?
There's 2x squared.
No, there's 2 terms with x squared.
Well, that's what I.
No, but I want you to combine them. I know there's 2 terms with x squared, but I want you to combine.
Oh, I thought you were asking me how many.
No, I want you to combine them, and then you combine the x's. So how many x squareds total?
So 5 minus 1 is 4.
So 4x squared. How many x's, Daniel? By the way, to do x squared here, an easy way to do it is use the caret key, and then tab. So how many x's?
There's the 2x, and then there's the 4.
There's 2x terms. What do they total? What do they add up to? See, ignore the x's. Just take the coefficients. What are the coefficients? Read them off.
4 and negative 6. Or is that minus 4?
No, you're backwards. You would set it backwards.
It's negative 4.
It's 2 and negative 4.
Right.
So it's 2 minus 4.
Negative 2.
Negative 2. Yeah, this is why we want to review. And I'll do the last one. 2 minus 4, also negative 2. You want to develop a method that you can tag onto, so you're never at a loss for how to combine them. See, this is the opposite of 4 minus 2. 4 minus 2, boom. But 2 minus 4 is the opposite. What are opposites? Opposite are the same number, equidistant from 0. You see, here's 0, here's minus 2, here's plus 2. Minus 2 and plus 2 are opposites. So this and this are also opposites, because that's minus 2 and that's plus 2. They're opposites. So in general, you might want to write this down somewhere. A minus B and B minus A are always opposites. I don't care what they are. 3 minus pi and pi minus 3 are opposites. And I have no idea what they are. They might be, I can approximate them maybe, but all I know is they're opposites. By the way, which one of these is negative? Which one's negative? The top one or the bottom? Yeah. Why? Because 3 is smaller than pi. Right? You know pi is approximately 3.14159, so 3.14 is good enough. But you see these little tricks that you want to hang your hat on. All right, so we check the answer. Yay! Number 25. Fractions. Okay, let's look at fractions. Fractions are something that you want to compartmentalize because they're difficult. So now I know that, see, to combine the x's, they're like terms. And they're like terms because it's x to the first power. I want to combine the coefficients. So I just ignore the x's. And what do I need to do to combine those? Can we do this?
You have to make them like numbers.
Which numbers then?
The bottom one.
Denominator.
Thank you.
Unique common denominator. And you don't want to make, you can multiply 6 times 12 and make 72 the common denominator, but 6 divides 12, so why not just make 12 the common denominator? So how do I change 5 over 6 to something over 12?
You have to multiply that
5.
by the 2 that.
So that's 10 plus 1 is over 12. So that's my answer. 11 over 12x. All right. So here's how you do it when you hit this. When you put your cursor in the box, you see the bottom lights up. There's your fraction right there. And all you got to do is put 11 tab 12. Oops. 11, not 1. Oops. Okay. And then if I do tab, now I could put 11x in the numerator, which is okay. It'll do that. Or I could put 11 12 times x like they did. As long as you don't don't drop the x down below the middle so it looks like it's in the denominator. See, that's always a problem when people write this. Is that 1 over 2x or is that 1/2 x?
That's 1/2.
So to avoid that, a lot of people just do this. There's 1/2 x, but now there's no question about where the x is. Same thing here. Typically, we don't get this one confused, but this one, careful. Okay, so 11x over 12.
You forgot the minus 4.
Oh yeah, that's good though. But see, I was in a hurry, but it gave me the second chance, and if I needed a third chance. All right, so that's good. Thank you. And then number 35, evaluate. Evaluate means plug the value that they're giving you for the variable, and just what's the answer? So if x is -8, what's x squared?
It's -8 squared, which gives you positive 8 times 8 is
All right, so there's two negatives, that's why the answer is positive. You see that? There's two negatives. So yeah, the answer is positive 64. And that is something you have to be careful with, because a lot of people get confused, or they get lazy. They forget that if I want to square the negative, I got to put parentheses, because these are not equal.
Right.
All I'm squaring here is the 8. Here I'm squaring negative 8. So it's negative times 8 times 8. There's two negatives, so they annihilate each other. And when you have an even number of negatives, the answer is positive. Here I only have one negative, so it remains negative. Okay? So be careful with that. Always remember what's your exponent's operating on. Number 39. So x equals 7. Okay, so I'm going to show you a shortcut to this. Watch. If you got a nice calculator like this, watch what I do. I say 7 store x. Store keys right there. See STO with an arrow. And now when I hit enter, from now on, x is 7. So guess what I'm going to put in the calculator? X squared minus 5x plus 3. I don't want to tax my brain. I just let the calculator tell me. Okay, so it's 49 minus 35 is 14 plus 3 is 17. I could do it mental arithmetic, but if you don't want to do it mental arithmetic, let the calculator do it. Because that's the way you do your taxes and your checkbook, and right? If you can. Any question about that? Number 43. This one probably with a cube. It's even more problematic. See, now x equals 2, so I do 2 store x. When I hit enter, now x is 2. It was 7, now it's 2, because that's what I told it to do. So I write x cubed minus 2x squared minus 6x minus 1. So yeah, if I did it by mental arithmetic, it would be 8 minus 8 is 0, minus 12 minus 1 is negative 13. So there it is, negative 13. See, this is 8 minus 8. See that?
Right.
So it's minus 12 minus 1, which would be negative 13. And the calculator verified that for me. By the way, on the calculator, you see the difference between the negative sign and the minus sign. The negative sign is raised up above the middle, and it's shorter. This is longer, and it's right in the middle. So this is a binary operator. You need two things to have a subtraction. A negative is a leading sign, changes a number, it changes its polarity. It makes it the opposite of what it otherwise was. So instead of just being 13, it's negative 13. So you see the difference between a negative and if you have a leading negative sign, we write it as a minus sign, but the calculator needs it to be as a negative sign. And it's right here in parentheses. You see that? This is your negative sign, and that's your minus sign. So this is a binary operation, and this technically is a unary operation. Although, is there a way around that? Well, yeah, watch. If I write 0 minus 13, guess what my answer is going to be? Negative 13. See, I can write the minus 13 as long as I put a 0 in front of it. But that's a lot of work. I just want to point out the difference between a negative and a minus. Although we slur it, we just roll with the punches, because in everyday lingo. Is 7 a solution for this? Well, plug in 7 for x. Do you get a true statement?
Yes.
Yes, you get 40 equals 40. So it's yes, it's a true statement. Right? If I put in 7 for x, that's 5x is 35 plus 5. I get 40 equals 40, which is true. Okay, now they want us to solve a linear equation. Remember how to do that? There's two things you can do to solve a linear equation. You can add or subtract from both sides of the equation. That's what they call it today. Do you guys know what transposition is?
You take what's on one side and put it on the other.
And change the sign. That's how they taught it when I was first in algebra. They call it transposition. I think somebody decided it was too difficult for a lot of people. So if I got x plus 3 equals 5, the modern way is to just subtract 3 from both sides because this is 0. And so you get x equals 2. And when you plug it in, you see it's true. In the old days, we would just go like this. You say, let's transpose it. When you get to the same place, you just eliminate this. See, now they emphasize getting rid of the 3 from the left-hand side. We used to get rid of it by transposing it. Mm-hmm. So if you hear that word, transposition, that's what it means. And you can do it with any number or any variable, any term you can transpose. Okay. So what's the solution to this one? If you add 4 to both sides.
Right. And that would give you -6.
-6. Good. Now you notice they give you the chance to write that it's identity or a contradiction, see? Because remember I told you, those are the 3 possible outcomes for any expression. Anything that looks like an equation. Just because somebody wrote an equation doesn't mean that it's not a contradiction or not an identity, or it has to be what we call a, what do we call those? There's a name for them. It'll come to me, I'll remember. Number 53. Okay, now I got x over 3 equals -9. How do I get the x to stand? I want x equals, I got x over 3. So what do I got? The other thing I can do to both sides of an equation is multiply or divide by the same number. Non-zero number. There's no sense in multiplying or dividing by 0. You can't divide by 0, and then multiplying doesn't do anything. So, well, I'll multiply both sides by 3, right? So my answer is? -7. Said the 1?
Huh?
You said 7?
Yeah.
Oh, okay.
Negative.
Yeah. 57.
I'm sorry, I'm writing on here.
All right, so now I have to do 2 things. I got to isolate the variables on one side and also the constants on the other.
You would take the 5 over the other side.
There's 2 ways to do it. You can do it however you like. It's your choice.
Because you have to make t on one side and then the numbers all on the other side, right?
Yeah, but there's no law that says the variable has to be on the left.
Right.
It could stay there, but I don't like it there. See, what I'm going to do is I'm going to add 6t to both sides and then subtract 43. You know why I did that? See, these add up to 0 and these add up to 0, and then I got 6t equals -48. See, I want a positive number here. I don't want to divide by a negative. So I got t equals -8 when I divide both sides by 6. If I did it the other way, I add 5 to both sides. It might be easier, but I got to be careful when I divide that I remember there's a negative there. So either way, it's your choice. So the answer is -8. Okay. 58. Got to do 2 things here again. But this one, they're all positive, so it's easy. If I subtract 15, what do I have on the right? 40 minus 15. No.
25.
And 25 divided by 5?
Is 5.
Yeah. So there it is, n equals 5.
And it's positive.
Right, that's why I said it's all positive, so it's nice, easy problem. Now you can use pencil and paper, you can use calculators, whatever you want for this. It's just a question of okay, 7 wide. This is where what I did here might have seemed a little over the top, but now this one is set up nice for this kind of work. You just have to figure out which side you want to move your y's to. And see, since this is 15 is larger than 7, I'm going to subtract 7y. And the minute I decided to subtract 7y, that means I got to get rid of the 37. So I subtract 37. See, these are gone, and these are gone. They vanished. I did two transpositions, is what I did.
Right.
And now I do the combination. I add them all together. And so y equals -5. It's my solution. Of course, if you're unsure, then you can check. So how do you check? Well, watch. I put -5 in for x, and then I say 7. I don't have x's. I don't have y, so I have to use x's. So 7x minus 3, and then 15x plus 37, or 15y plus 37. You get the gist. And guess what? Minus 38 equals minus 38. When I plug it into the original equation, the solution is the same as my solution to the bottom. See, this equation is so straightforward. If I said, what's the solution to it? You just read it. That's the solution. Y equals -5. So when I plug that back into the top, I get -38 equals -38, which is true. That's my check. Remember doing checks when you were, yeah. Okay, so -5 is the solution. All right, so that's it for chapter 6.1. All that algebra review. Now what we're going to do is we're going to switch gears and we're going to go to section 6 and we're going to do graphing. Another tool that we can put together tomorrow with some other stuff. But the thing here is to learn how to use the graphing on the MyMathLab. You guys haven't used MyMathLab previously, have you?
I have.
You have? Okay. All right, so I'm going to close this section. And we're going to go over to section 6.6, graphing linear equations. We'll start with some definitions, work our way up to this. An illustration of all the points whose coordinates satisfy an equation is called, what do you think is the right answer? What do we call that?
I'm not even sure where you are.
Are you online with me? You should be seeing what I got. Oh, you're not on Keiser Live. Why don't you on Keiser? You know how to do it? You know how to do it? Oh, let me show you how. You have to go to your Blackboard. The Blackboard, please. Keiser Live. Course room. Join. I never had it blocked.
Here, you want me to show her?
She's on.
Okay.
And there it is. That's exactly what we're doing. What's on the TV is now on yours.
Okay. Thank you.
Yep. So which one is it? What do we call that? Illustration of all the points. I showed you one earlier. Remember 2x plus 3y? What do we call the illustration of all the points that satisfy that?
Isn't it the coordinate?
No, the coordinate system is the whole plane with the xy axis.
Ordered pair?
Ordered pair is just one point. I didn't think this was that difficult. Graph. It's called a graph. Yeah, that's what we call a graph. The graph of a linear equation is a straight line. That's what we're referring to. I didn't mean it to be that difficult.
No, but I learned something. I mean.
Oh, okay. Now to find the x-intercept, I might as well talk a little bit about what we do. Actually, let me start. Well, we've been working with the x. We just x's. Now we're going to do x's and y's together. So we have the x-axis. We arbitrarily have some point that we call 0, and then we just have a unit. And these are our integers, our lattice points. They're called different names, but integers will do. And it's just some arbitrary length, and we set it up so that that's our number line. And then we take another copy of this at 90 degrees, and we go through the 0 point at 90 degrees, and we call it the y-axis. And we can use the same or different, doesn't really matter. I'll keep it the same. And going up in the direction of the arrow is positive y. Of course, going down is negative. And so that's 0 for both x and y, and that's called the origin. And the address for the origin is the ordered pair 0, 0. The reason it's called the ordered pair is because the first entry is the x and the second entry is the y. It's always ordered alphabetically. So x comes first, y comes second. So notice that this point here is 2, 1. This point here is 1, 2. See, 2x, 1, 1. 1x, 2y. So the ordered pair is just a point, the address for a point in the plane. So another name for the line that is the x-axis is y equals 0. That's the equation for the horizontal line, because y is always 0 on that line. It doesn't matter what x is, because y is always 0. And the y-axis, x is equal to 0. It's a vertical line. The only difference is this has slope equal to 0. Remember the y equals mx plus b? Then both m and b are 0 for that particular straight line. It's a horizontal line. It's the x-axis, but it's still a line.
There's no slope on it.
But there's no slope on this one. It's undefined. You guys know what undefined means, I hope. If not, I'll explain it to you real quick. Undefined, in all seriousness, in the field of complex numbers, of which the real numbers are a subset, there's only two viable operations that we can use. One's addition, and the other one's multiplication. There's no such thing as subtraction. There's no such thing as division. Those are artifacts that we use on everyday lingo to make it easier, especially K through 8 when you're just learning. Because it's a lot easier to write this than it is to write this. Because we don't even talk about negative numbers. But that's what we're really doing. We're adding a negative because there is no subtraction. But we say, oh, we're going to truncate the plus times the minus and just call it a minus sign. And we create this operation. But it doesn't have all the properties of addition. And so we define subtraction from addition. We define division from multiplication. So when we say that 24 equals 3 times 8, we say that 24 over 3 equals 8 because this is defined from this. Because if I divide both sides by 3, I get this. So if I say 24 divided by 0 equals, I don't know, so I pick my favorite letter, I say it equals k, then by definition, it should be true that 24 equals k times 0 if I multiply both sides by 0 somehow. But what's k times 0? 0. So it can't be equal. They can't be equal. So there is no definition for this. I can't redefine it as a multiplication. So we say it's undefined. See, this is defined because of this. Any division where you don't have 0 in the denominator is defined. This is the only one that you can't define. So that's what it means. It's a math lingo, but a lot of people get scratch their head. And you know what most people say? Oh, just let it be equal to 0. But you can't divide by 0. I can divide 0 into as many parts as I want. If I got no dollars and I divide it equally amongst all three of us, how much are we each going to get? $0. But if I have $3 and I want to divide it into 0 parts, it doesn't make any sense. You can't divide it into 0 parts. You can divide it into 1 part, 2 parts, 3 parts. You can even divide it into 5 parts or 10 parts. but you can't divide it into 0 parts because you can't do it. It's undefined.
Right.
All right, so that's what it means. So to find the x-intercept, what do I have to do? What do I set equal to 0? If I want to find the x-intercept, I want to find where the graph crosses on this line. I set 1 equal to 0. Why?
Why?
I set y equal to 0. And I'm guaranteed to be on the x-axis. Vice versa, to find the y-intercept, what do I set equal to 0? X. I'm guaranteed that I'll find the y-intercept. And that one's a lot easier because you see right here, if I set x equal to 0, I get y equals b, which is the intercept. Right? It's much more difficult on the other way because there is no equation like this. I mean, I guess you could. I guess you could. I don't know. We don't want to go there right now anyway. All right. So, and then the ratio of the vertical change to the horizontal change for any 2 points on a line is called, do you remember that? So let's say I got these 2 points. This is my line. I want to know change from here to here. So remember what I do? I call it the slope. I take y1 minus y2 over x1 minus x2. So it's the change in y divided by the change in x. And for this dotted line, if I start here and I call that y1, then this is y2, this is x1, and this is x2, and I get 1 over minus 1, so the slope's -1. It's a -1 slope, which means you would go down 1 for the y and plus 1 for the x, or vice versa, because both of these are the same. You know, the minus sign could be in either place. This is still -1. So if I do this one, I go up 1 to the left 1. If I do the other one, I go down 1 to the right 1. So I still end up back on the line. That's my slope. That's my change in y divided by my change in x. So that's called the slope, which we'll get into a little later. Should be a review thing, hopefully. And then there's 3 methods we're going to use to graph equations. One is the simplest thing, just plot points. Like let's see, this would be, I think I can use the same 2 points there. I know the slope now is -1, so if I take one of the points, remember the slope, point slope form? Mm-hmm. Okay, that's y1, I'm sorry, y minus y1 equals m times x minus x1. It's just taking this, moving this up here, and then instead of using both points, just use one of them. So you have y minus y1 is 2, and m was -1, and x was 1. So there's your formula. Y minus 2 equals -x plus 1, so y equals -x plus 3. So there's your intercept plus 3. It's not really drawing really that well, but there's your equation for that dotted line, using the notion of, this is called the point slope, where you take a point, x1, y1, and the slope, and all you're doing is taking this formula and just rewriting, multiplying both sides by x1 minus x2. You see it? But instead of calling it x1 and 2, I'm letting these two be variables and these two be a point. See that? So we just pick points. So if I wanted to draw this, I would just pick points. I could just pick values. If x equals 2, then -2 plus 3 is 1. And if x equals 4, then -4 plus 3 is -1. that's 2 points. I could use those to draw it. So 4 negative 1's here, and 2, 1 is there. So there's my 2 points to draw the line. So just plotting points, just picking points. That's one way. Another way is to use the intercepts. I could use this formula for the intercepts. So for the intercepts, the y-intercept's easy. It's +3. When x is 0, y is 3. But when y is 0, if this side's 0, then x has to be 3 also. Right? Because -3 + 3 would be 0. So I could use it plotting specific points called the intercepts. And the third way is the point slope. I could take the intercept and use the slope. There's my intercept, and I could use the slope as -1/1 and be minus, and there's my 2 points. So there's 3 ways for us to graph. Plotting points, plotting intercepts, or using the point slope form. So which one's the right answer? Plotting points, using intercepts, using the slope of the y-intercept. So D. And I'm gonna show you each one of those now, going forward here. So the first one we're gonna do is plotting points. We'll start with number 9. And now we get to actually use the graph. See, there's a graph. Oh, I take it back. First, we're gonna just plot points in general. Is that big enough? You know what? I can make it bigger. See, I can go like this. There we go. So we're going to plot 5, 1. So 5, 1, I just grab it, move it over to 5, and then I go up 1. So now I'm at the point x equals 5, y equals 1. Check my answer. And you notice it doesn't tell me where I'm at. I have to make sure that I'm there. See, normally on a lot of these, as you move that, it tells you where you're at. But they don't want to give it away. They don't want to let the machine give it away. They want you to plot it. Okay, so we have to deal with that, I guess. Number 11 is -8, -7. Notice I accidentally moved it. So I go to x equals -8, and I go down. It's in the third quadrant. I didn't tell you about quadrants, did I?
Yeah.
This is the first quadrant, and they're usually in Roman numerals, capital Roman numerals. So quadrant 1, quadrant 2, they go counterclockwise. Quadrant 3, and quadrant 4. And the quadrants do not include the axes. The axes are what separates the quadrants. So the axes are not in any quadrant. They're the structure that holds it all together, and then we just call these 4 quadrants. So here they're both positive, here they're both negative. Here they're opposites. Y is positive, x negative, x positive, y negative. So there's 4 possibilities for sets of ordered pairs. Hey, I got it right. Okay, that was -8 and -7. See, as soon as I saw them both being negative, I knew I'd be down in the third quadrant. All right, 7, 0. I'm on an axis. Which axis am I on? Well, if y is 0, then I'm on the x-axis. So x is 7. There it is. See, these are really important. It's on your handout about these. Those are special equations. They don't look like y equals mx plus b because they're special lines. They're horizontal and vertical. Because they have special slopes of 0 and undefined. They're special. I don't know how better to say it than they're special. 19. So you'll be seeing a lot of these in your homework. They should be straightforward. These you don't have to do anything. They already give you the center. As soon as you put the cursor on it, it lights up blue square. It means it's ready to move. Once again, we're in the third quadrant. So -1x, -4y. And check answer. Okay, I'm doing good, huh?
I would hope so. Yeah, right?
Oh, you never know, believe me. I'm getting old. I make mistakes too. I don't make them on purpose. Now, this one, there's a lot of numbers there. It's very disconcerting, but there's halves. See, there's 20 lattice points here. See, they go between one and two, there's two tick marks. See that, there's one in the middle. So there's two little squares. So these go by halves. So when it says 2.5, 7.5, it's the first quadrant. So you go to 2.5 on the X. That's halfway between 2 and 3. Then you go to 7.5 on the Y. You have to go halfway between the 7 and the 8. Now it's nice that they have these the dotted lines help you to see where they were. So between 2 and 3 and 7 and 8, so we're good to go.
It's so small, it's really.
Well, you can open it up like I did when you do your actual work. Did you see that, how I opened it up?
Mm-hmm.
Yeah, okay. Okay, now we're going to name the point. Let's see if this is working backwards. Now they give us the point, we have to name it. 29. Anybody want to try it?
Well, it's X is negative 6, and then Y is negative 2, right?
Okay, so I'm going to do this wrong so you can see how to do it right. So there's negative 6, negative 2, and it's going to say that's incorrect. See, it says make sure you've enclosed your answer in parentheses. Because if it's an ordered pair, it has to have parentheses. Oops. Got to use the shift key. So now it's an ordered pair because it's in parentheses in that lingo. So now it's correct.
Okay.
All right. Are you on Keiser Live?
Yeah, I'm looking
You
at
watch
what
it?
you're looking for.
All right. I didn't check. I didn't really. I just why I asked. Okay, number. Let's see.
What happens if you use that little box with the arrow on it? See how it has the magnifying glass and then what is that?
It opens up into a new
A new window?
Yeah, new window.
Oh, okay.
I just used the plus one, just make it bigger. Okay, the coordinates of A are what? It's your turn, Danielle.
In parentheses, 7, negative 8.
7, comma, negative 8.
Got a 9 in there.
Thanks.
No problem.
It's a fat fingers. Very good. You guys are good. Caught right on. Okay, now we're going to go to graphing. Now that we know how to get the coordinates and whatnot, let's do 37. Let's see what it says. Okay, now I take it back. It says determine which satisfy the given equation. So in other words, which of those 3 points are on the line of the graph of the line there. So you just plug them in, see if you get a true statement. So if x equals 1 and y equals 0, I get 3 equals 3. Right?
Mm-hmm.
All right, so that's B will work, but it doesn't mean it's the only one. Or it could have been none of them, or it could be all of them. Now 5, 3, I would get 15 minus 12. That's 3 equals 3, so that works. And 0, 5, that's negative, or 20 equals 3. That's not true. All right, so it's B and C. Now notice that they're not in the right order. The order up here is different than the order down here, so just wanted to point that out. I don't know why they do that. Maybe it's a game they play. Okay, that was 37. Now we go to 43. We want to graph the equation by plotting points. Okay, so who wants to give me a point? Yeah, you just what you normally do here is pick values of x and calculate the value of y.
So you can just put like 7.
So, okay, x is 7. What's y?
8.
All right, now this is how you do this. Watch. See this right here, this icon? When you hit that with your left, it's called a line tool.
Uh-huh.
See, now it's ready. So you said 7, 8. So I go over 7, 8, and I hit. And then see, now when I move, it's going to form a line. So now I need a second point. You pick an x.
6.
So if x is 6, what's y? 6 plus 1. 7. All right, so there's my line. You guys picked those 2 points, right? So there's the line. And if I check answer, that's correct. So that's just plotting points. You just pick values of x and solve for values of y. That gives you your order pairs. I mean, you could have picked intercepts, but they just trying to avoid that for right now. Okay, this one, next one. Let's do the same thing. Each give me a point. We'll start with Danielle first. Pick an x and solve for y.
6.
6 for x?
Yeah. Ooh,
It's not going to fit.
So it's
I have to. They both have to be between -10 and +10.
2.
So x equals 2. What does y equal? Put in 2 for x. Can you do that in your mind's eye?
Yeah.
So 3 times 2 is
6.
-1.
5.
So 2, 5.
Yeah, I said that, like, I was saying that out loud to myself, and I wasn't sure if I was.
No, that's what we're doing, yeah.
Okay.
We're just plugging in a value for x. Okay, so remember, hit the line tool, and then you want to do 2, 5, you said.
Yeah.
Okay, so there's the first one. Okay, Maria. Get a value for x.
4.
Okay, so 12 minus 1 is too big.
I want -4.
Okay, so -4, still too big. That'll give you -13. Try -3.
-3.
So 3 times -3 is -9 minus 1 is -10, right? So when x is -3, y is -10. Right? All right, so there's my line. Very good. So that's just plotting points. That's all we were doing, just plotting points. Maybe I should have written them down here. So we have y equals 3x minus 1. Danielle picked 2, so 6, we got 2, 5, and you picked -3, Maria, and that was -10. So there's my order of pairs. Now they're written in the table form, so they don't have parentheses and the commas, but each line is an ordered pair in table form. So that's what we did. You can do that on the side for yourself and then plug them in if you get confused. Because there's no rush on these, you just want to get them right. Okay, now we're going to use intercepts. Let's go to 53. Now we're going to force both x and y to be 0, which you can't always do, but when you can, it's nice. It's real easy. You see, for this one, I have x plus y equals 5. And we're going to get a lot of equations like this in our work. Look, here's what I do. When x equals 0, that means it's gone. Look, y equals 5. And when y equals 0, it's gone, so x equals 5. So there's my intercepts. See how easy that is? All right, so then I can't do anything until I hit the line tool. See, there's nothing going on. But once I hit the line tool, and now I go over the graph, see, it's ready for my points. So 0, 5 is here, and 5, 0 is here. So there's my line.
No, because it's negative. It's a -5.
Oh, I wrote +5. Okay, so, that's good. Because now how do I get rid of this? By the way, then, if it's -5, then these are both -5.
Right.
All right, so I made the mistake. Now, how do I get rid of that? What you do is you go clear. See the clear down here? So now I start over. I got to start with the line tool again. See? So now I go -5, 0, and 0, -5. Check answer. Okay. I didn't do that on purpose, but it worked out well. Okay, another one for intercepts. Okay, this time I'm gonna ask you guys to do the intercepts. Who wants to go first? I need the, Danielle, I need the x-intercept. Let y be 0. So just solve 3x equals negative 9.
3.
Negative, negative.
Negative.
So what's the ordered pair?
I'm not sure. I need your help.
Which one did you let be 0?
We said the y was going to be.
Okay, so that's ordered pair. Which comes first? X or the y?
Yes.
Yeah. And you said x was? You have to solve it again. 3x equals negative 9.
We said 0 was y.
Yep.
So x is 6.
No, 3x equals negative 9.
3.
No. Close.
I don't know. I'm getting overwhelmed.
All right, so 9 divided by 3 is 3, but negative 9 divided by 3. It's the opposite.
Negative 3.
Okay, so negative 3 comma 0. Yeah. That wasn't so bad, was it? All right, Maria, I need the the y intercept. So let x be 0. That one's easy.
Negative 9.
So what's the ordered pair?
So 0, negative 9.
There you go. Okay, so before I check that, let's look over here and see how we did that. This time I won't forget the negative. Okay, so when y is 0, that's what we did. We did 3x equals negative 9, so x equals negative 3. And when x equals 0, it's right there, y equals negative 9. A little easier. But you maybe on the side you want to have this because you need a place for the calculations. So just have a scribbling pad on the side so you can do that. Now we're going to check our answer, and we got it. Okay. So then we did plotting and intercepts, and now we're going to define the slope, and then we're going to use the slope. So in number 63, we're going to use the slope. The formula's still up there for the slope. Plus, we can use the calculator now if we have to. So they want the slope between these 2 points, 4, 3 and 7, 9. So let's just go ahead and plug it in. Now I'm going to pick the first point is y1. So it's 3 minus 9 divided by 4 minus 7. See, x1 and y1 have to be first. You can't split up, you can't turn these around because then it doesn't work. You see what I mean? The ones and the 2's always go together. I don't care which way you start, but you got to keep them like that. If you start on the left, you got to start on the left for the x also. So then I hit enter, and the slope is 2. Actually, 2 over 1, but you could write 2. So that's all you do. You just apply that formula for m. The difference in the y's divided by the difference in the x's. Now, if you have negative values for x's and y's, you might have to use parentheses, right? You have to be careful with that. I don't know if there's one like that or not. Let's see if the next one's like that. Number 69. Oh, let's back it up for a sec. Let's do this one. Determine the slope. Okay, see now I got a bunch of negatives. So if I start with, I got to put negative 4. I can't put minus 4. And I have negative 4 minus a negative 8. So I can do this on this calculator, believe it or not. I can put a double negative like that. See that? Divided by, and then I start with the negative 3 minus 6. So I don't need a negative on that one because it's positive. 6 is positive. So my slope, now what do? They want an integer or a simplified fraction. So on this particular, you do math, you see it's already queued up for you. It says frac, F-R-A-C, if you hit enter. So minus 4/9, if you don't recognize that as a fraction. So the slope is negative 4/9. So we can do it this way. Negative 4 tab 9. I'll just put the negative in the numerator. If you did it by hand, it might be a little simpler, I don't know. You would have negative 4. Now, what I usually do, I just change the sign. A negative of minus 8 is plus 8. I just do it mentally. And then negative 3 minus 6. And you get 4/-9. So there's your negative 4/9. You guys should remember, I think it's on the handout too, for a fraction, these are all the same number. You can have minus 4/9. You could write it as minus 4/9, or you could write it as 4/-9. They're all the same. There's 3 different places to put the negative sign, in other words. Okay, so when we calculated it here, we got the negative in the denominator. The calculator told us it was negative in the numerator, and that's where we put it. I think if we would have put it in the denominator, it still would have accepted it as correct. Pretty sure that the computer understands that. Okay, can you guess what's going to happen with this one?
That's going to be
Yes, because 3 minus 3 is in the denominator. X1 minus X2 is 3 minus 3. And what happens when you have 0 in the denominator? Undefined. There's no run. There's no run because there's no change in the X. So it's like when you have a flat line, a horizontal line, there's no rise because there's 0 in the numerator. Yep, pretty cool. All right, so now we are going to use the slope and the intercept. I like this one. I like the intercepts and I like this one because they're straightforward. See, and I know the slope is 1. That's the number in front of X. That's the M. But I don't just say 1, I say 1/1. The rise is 1 and the run is 1. And the intercept is minus 4. So I hit the line tool, I go to my intercept. There it is. And now I do my slope. I do rise 1, run 1. There it is. And so that is the line. Okay? I think these are the easiest ones. So this one, I hit the line tool, I go right to minus 1, which is the intercept, the y-intercept, and this slope is 5, which is 5/1. So I go up 5, 1, 2, 3, 4, 5, and I go to the right 1. There's my, now we can double check it real quick. That's the 0.14. If I put in 1 for X, I get 5 minus 1 is 4. So I know it's the right line, correct line. Questions? So those are the 3 methods of drawing line. The lines they give us are usually straightforward. They're easy like this. Once we get we know right away how to draw them. You know, like that one too. That's pretty easy because once you can do intercepts, I think it's pretty easy. And otherwise, you could just do slopes. Let's do this one. So the intercept is +2, the y-intercept. So I hit the line tool. I go to right to my intercept, and then 5/2. So 1, 2, 3, 4, 5, 1, 2. There's my line. Oops. I had the wrong intercept. It should be 3. Okay, so let's do it. I'm going to see something. If I just move this up, if I move both of them up, will it do it? Yeah, you could just grab and move them up. There you go. That's another way to correct it. All right. So you think I don't make mistakes? You see how I made a couple already. You got to watch me. I'm dyslexic, you know. I'm dyslexic. All right, so now they want us to find the equation for the line. So what do we need? We need the slope and the intercept, or we need 2 points. One or the other. Either way will work. You just have to remember our formula. Y equals mx plus b. That's the formula that we'll always fall back to. Because the x and the y are a point, and the m is the slope. So if I have these three, I can solve for the intercept. And if I have this, well, we'll see. So what do we have here? We have 2 points. We have 6, 0, and 0, 5. So we have 6, 0, and 0, 5. Right?
Yeah.
So I can figure out the slope pretty easy. So if I start here, I'm going to start here as my y. 5 minus 0 over 0 minus 6. So it's 5 over minus 6 is the slope. And I have 2 points. So I can plug them in. I can use y equals 0 and m equals minus 5 over 6 times x plus b. The 6's cancel, so I have 0 equals minus 5 plus b, so b equals 5. So I have m and I have b. So my graph is y equals minus 5, 6, x plus 5. And you can check real quick. If I plug in y equals 0, then if I plug a 6 in, I get minus 5 plus 5 is 0, so that works. And if I plug in x equals 0, I get y equals 5. So this is the equation for those 2 points. So I solve for the slope, and I use the slope and one of the points. I used x equals 6 and y equals 0. See, x equals 6, y equals 0, and m. Once I had these three, I could solve for b. And then once I know m and b, I know the equation. Follow that? Now there's another way to find the slope here. If I just count, watch. If I go down from here, I go 1, 2, 3, 4, 5. That's negative 5, and then positive 6. So my slope is negative 5 over 6. And I know my intercept, it's right there. It's y equals 5, or b equals 5. So I can get the slope and the intercept just by reading the graph. Or I can do algebra. It's your choice. As long as you have an understanding of how you want to attack it. I'm not saying either way is better. I'm just trying to give you alternatives. All right, so the graph. Let's put it in there. Now, putting it in, you have to put in y equals, and we want minus 5 tab 6 tab x plus 5. Yeah, plus 5.
Triangle.
There we go. Thank you. So that's our answer. Any questions about that? So this is working backwards. This is, you have everything. You know, if we have the formula, think about it. After you have the formula, you can check it. Look, if I plug in the intercept plus 5, then I do the slope 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, 6, positive. Right? I put the negative upstairs, so I go down. Follow? All right. Let's do another one like this. 81. All right, so let's make this one real easy. What's B? What's the intercept? Y-intercept. 5. So B equals 5. So what's M? See the 2 black dots? Start at the bottom one. You go up how many? 4, and you go to the right. So both 4 and 3 are positive because you're going up and to the right. So the slope's 4 over 3, 4/3. So it's Y equals 4/3 x plus
The five.
5. That was easy, huh?
Yeah, that one I understood better.
Yeah. Now,
And that was so much easier. And yeah, the way you say it, I'm not gonna lie, the second time around, I say, now I can understand what you were saying before I had no idea.
well, see,
Oh,
if I were going to do it algebraically, I need the 2 points. So I have 0, 5, and 3, 9. So I have 0, 5, and 3, 9. So I'll start here. The slope is 9 minus 5 over 3 minus 0, and so I get 4 over 3. And I know that b is 5 because it's right there. That's a b. So y equals 4/3 x plus 5. So you can read the slope off of the graph as long as they're integers. If they're halfway between, then it's tough. But as long as these are called lattice points. That once you fall right on where they cross, those are lattice points. So, see, like this wouldn't be a lattice point because it's between.
right.
But these go right through the intersection of vertical and horizontal, so they're lattice points.
Oh, yeah.
That's what we call them anyway.
Is that what you're talking about right there? Yeah, okay.
All right, so we'll finish up with some of those special equations. 83, x equals 4. All you have to think about is horizontal or vertical. It's on your handout. Part letter A. What's it say for x equals A? What's it say for x equals A? Paragraph A. Paragraph A. It says it's a vertical line, x equals. So x equals 4. So it's a vertical line. So how do we draw that? You just pick any 2 points where x is 4. You pick the intercept and any other one. Doesn't matter. There's your vertical line. X equals 4. You see it? And what's the slope?
There isn't a slope.
So what do we say?
0.
No.
So it's undefined.
0 is a horizontal line.
Undefined.
Zero is nothing, but it doesn't mean it's not a slope. It's a specific slope that means there's no rise.
But it's on the 0.
It's undefined means there's no run. That means it's a vertical line. It's undefined. Okay, that was 83, 85. Y equals -6.
So that one's on the X. So it's on the axis. So it's
What's it say? What's it say for y equals b?
opposite and horizontal.
Yeah. So where's y equals -6?
To the left. Yep.
No, that's x. That's the x-axis. The y-axis.
Oh, that's right. It's this one. So it's. Yeah.
It's a horizontal line. You got to first find it. There it is, -6. Any 2 points. It's a horizontal line. There it is.
Okay.
See it? If you remember that the x-axis is y equals 0 and the y-axis is x equals 0, you got it. Because you remember the y-axis is horizontal. But the characteristic for the x-axis is it doesn't matter what x is because y is always constant at 0. Because there's no rise. It doesn't rise. All right? All right. Let's try. Oop. I forgot to answer the question. We'll do another one here because I forgot to answer the second question. Y equals 2. So hit the line. It's just right here. Y equals 2. It's a horizontal line. See? And then it says, what's the slope?
It's 0.
That's right. The slope is 0. Remember I showed you that? Because both m and b are 0. So y equals 0. Because that's the x-axis. Well, for the line y equals 2, b is 2, because it's the y-intercept. You can see there's the y-intercept is 2. But if the slope's 0, it's a horizontal line. Okay, good. I almost blew that one. Let's see, one more here, 89. Let's see what 89 is. Oh, they want us to determine what's the equation for this graph.
So X is -1.
There you go. So you got to write it out. X equals -1. There it is. Got it. So on this handout, I have a lot of stuff, but I don't have everything. So, you know, it's about 95% of what we need for test number 1. But there's some things that just aren't here. There's a review of exponential rules if you have reason to need those. But a lot of the things we discussed: intercept, slope formula, slope intercept equation. We'll talk about parallel lines a little bit later, horizontal and vertical lines, and then some of the stuff on the other side we'll get into tomorrow. So that's it for homework 1, ladies. You are gassed up, ready to go. Any questions? So there, I told you, usually 6:30. We had some business to attend to it. We usually are done by 7. 6:30. It's between 6:30 and 7. Hope that's okay.
Give you plenty of time to work on it.
Yeah. The way I think about this is, if you have an hour or so to spend on this when you get home, I'd attack it. Let's get most of it done. I expect you guys to get, 95 and higher on all these. You might make a couple of simple mistakes here or there, but with a chance to have a second chance, you should be able to get high scores. Because I want to jack you up on these because the tests are going to be a little more difficult, because you don't get to see if your answers are right or wrong until you're done.
Right. Yeah, that's the thing.
We're just prepping for that. So, thanks for coming, and I will see you tomorrow.
See you tomorrow.
Okay.
Bye.
I really do appreciate you guys getting all those assignments done ahead of time. It really.
No, thank you for the message. Yeah. That helps.
Well, we didn't have to waste more time today getting ready now, so. At least we have a small class. Sometimes when there's like 8 or 12, then it gets a little bit more.
It's a little bit more difficult. Yeah. All right, Dr. K, have a good night.
Okay, drive carefully. See you tomorrow.
Bye, nice to meet you. See you tomorrow.
Okay. Oh, I forgot who we're talking about. All right, shut this down. Oh, I gotta stop the recording.